So as I was starting to say before, ACEP's research mission is to meet state and local need for applied energy research. And we do this in part by providing practical solutions to real-world problems. And I think we know that wind diesel in remote communities is full of real-world difficulties and problems. So what ACEP does is verify for performance of equipment against manufacturers' claims. We can assess technical and economic feasibility through various projects, and we'll talk about that more as we go along. But most critically, the university can really serve an important function as being an impartial agent on behalf of Alaska communities and agencies to make sure that we're investing our dollars wisely on energy projects that make sense. So one thing that ACEP has worked to do is identify these areas of technology gaps, areas where us in our unique situations with our unique climate and unique resource availability really should be leaders and really stepping up in various technologies. And wind diesel was certainly one of these areas that ACEP identified early on as being of critical nature to our state and internationally as well. So these three founding entities, ACEP, NREL, and AEA, got together to form WIDAC, the Wind Diesel Application Center. And its main purpose is to support the broader deployment of cost-effective wind diesel technologies to reduce and or stabilize the cost of energy in rural communities. So we focus on three main areas: research and development, technical support, and workforce development and education. And I just wanted to introduce WIDAC a little bit more broadly so that as we're throwing the term around, folks understood really where that came from. But Alaska is what this presentation is about, and Alaska is full of high-quality wind resources, especially in areas along the coast. And Alaska's first project was installed in Kotzebue in 1997, and many of you are familiar with that project and actually have probably visited that location. And since then, 1997, as James mentioned, over the past few years, there's been significant growth in wind diesel to the point where we now have, since February 2011, nameplate capacity of about 13.1 megawatts. So for those of you in the outside, 13.1 megawatts certainly doesn't seem like a whole heck of a lot, but for us up here, we're really proud of our 13.1. And with recent construction projects that'll be going on over this upcoming summer, there's approximately 10 more under construction, and we should increase this capacity by another 4 megawatts. And this is of rural projects. So in part due to our, the wisdom of the state and the efforts of many of these entities that we've already discussed today, the Renewable Energy Fund has invested a significant amount of money in wind diesel projects. So you see in this chart on the left-hand side, on the bottom left-hand side of the chart, since 1997, you can see where the Kotzebue wind system initially was being constructed to where we're at now in the high period of growth since July 2008. But the key thing to take away from this is that 87% of our wind diesel systems are less than 4 years old. So the total installed capacity represents roughly $87 million of investment, and at least $23 million of that from Native corporations and other private capital. So I wanted to take those of you who are not very familiar with our projects on a sort of a photogenic tour of Alaska wind systems. So I'm going to start off with Delta Junction, and Delta isn't necessarily a wind diesel system, but I wanted to highlight it because this is where we're first starting to install some unique and larger scale wind turbines, including the 900 kW EWT that you see in the photo here. We can bring us to Unalakleet, which was recently installed with 6 Northwind 100s, and they've recently upgraded their power plant, and you're going to hear more about the Unalakleet system later on this afternoon. We can go up to Kotzebue, where we now have 18 wind turbines, including 15 of the Integrities, then the AOC 1550s. And Kotzebue is upgrading their wind system, and will be now installing over this next summer 2 more mid-size wind turbines, potentially the EWTs. Okay, that can bring us out to Wales. There's been lots of discussion and PowerPoint presentations about the Wales over previous wind diesel workshops. Wales has 2 Integrity turbines, and it's a high penetration system which was originally designed to run diesels off. The This is a picture of Nome, a Banner Peak project, which I'm going to talk about in a little bit more depth, where they've recently installed 17 of these integrity turbines. Okay, we can go down to Tooksuk Bay, where there's 4 Northwind 100s. And we can go to Kokkinok, where you'll see these on Saturday, where they've installed 2 90 kW V17s remanufactured. We go way out to St. Paul Island, where they've installed 3 225 kW Vestas turbines. And over to Kodiak, where recently they've installed 3 1.5 megawatt GE turbines, representing the first very large-scale wind project in the state. And Darren Scott is here. Darren? Well, anyway, we'll be hearing a little bit more about the Kodiak project as well. So what we decided to do over the past year, we wanted to make sure that we could start collecting this wind diesel database, as Chris Rose was referring to. There's a lot of systems that are being installed, and a lot of growth is expected over the next few years. So we wanted to make sure that as these systems are being installed, we can see exactly how they're performing, what the performance is, and perhaps look into the future and see what could be done better. How could we make these systems more cost effective and ultimately save more money for the residents living in these communities, so we can increase the viability of living in some of these rural, remote communities. So this, we had a report which was funded by the Alaska Energy Authority and the Denali Commission, and it was co-authored by myself and Ginny Fay. Ginny, if you're in the room, could you please stand up? Wonderful. Thank you, Ginny. So Ginny is an economist, and so if I already have had numerous people come up and have some questions about the paper that we've recently put out, and we'll have available during our poster session on Thursday. So any questions you can, with regard to the economic analysis, please see Ginny. So what you can see by this slide is that there's a big cross-section of existing systems, systems under construction, and pre-construction projects. There's a lot of activity going on. And also there's a very diverse cross-section of the types of systems that are installed. And as you can see by going quickly through those, the pictures of projects throughout Alaska, we have small scale, representing Perryville, where they've installed 10 2.4 kW Skystream wind turbines, all the way to Kodiak with the 3 1.5 megawatt turbines. So we've got small, we've got large, we have low penetration systems, high penetration systems, we have single utilities that are developing projects, and we have larger co-ops like Alaska Village Electric Co-op, which has multiple communities installing the same similar approach with medium penetration systems using the Northwind 100s. So it's very diverse, and what we were trying to do through this research is capture, hey, how are these systems doing? What is the cost of that wind energy? And what are some things that we can do to increase the benefit, the public benefit of these wind diesel systems. And so what we found out was very interesting, that when you look at some of the larger scale systems, when you have economies of scale, which is hard to develop in wind diesel systems, or if you're able to capture and utilize federal tax incentives by using and leveraging private dollars, we could get wind energy down to less than 10 cents per kilowatt hour. And then on the same side of on the opposite side of the spectrum, if you have communities which are installing 1 or 2 turbines in a lower penetration system in a wind class, which obviously isn't so great, we can have wind energy costing over 50 cents per kilowatt hour. So it's a very big spectrum. And 50 cents per kilowatt hour might not necessarily be a bad thing if, like in Perryville, for example, you're paying 95 cents per kilowatt hour. So there's a lot of relativity in here. So Nome, as a case study, Nome is an interesting project where they've, this is a project that's managed by Western Community Energy and owned by Bering Straits Native Corporation and Sitnasuk Native Corporation. So they installed 17 of these Integrity wind turbines. And this was during the time when Integrity was going through bankruptcy and dealing with some tremendous difficulties in getting parts and components out to this site. In addition, this was the first power purchase agreement of a wind diesel type system with an independent power provider trying to sell their wind energy to to the utility in Nome. So that process was a had a big learning curve and took about a year to get that power purchase agreement in place. So this construction project actually went up fairly quickly, but then went through some hurdles as they struggled to make this turbine work in the really harsh environment and harsh climate that Nome is, with heavy icing. So it's neat. I think this is a really good success story because you can see on the top graph here, the capacity factor in October 2009 was 6.3%. A lot of turbines were down. There was significant maintenance issues, but they were out there on a real consistent basis every day trying to make these things get the capacity factor that was modeled and that they really should get. And so in April 2010, they're up to 23% capacity factor, and now they're averaging about 25. So it's really exciting to see this project happen, but I think it really highlights in Alaska and a lot of other remote communities the amount of dedication that is really needed on behalf of the utility or the project developer to really make these things successful. It's a lot of effort. You can't just install a project and walk away and expect it to continue functioning without having a really long-term operation and maintenance plan in place. So with the medium penetration systems in Alaska, this is where Alaska Village Electric Co-op, AVEC, has taken ownership necessarily of this type of system. So in Tooksuk Bay, they're seeing average penetration of 24% and average capacity factor of 26%. And this is very common for all of their communities, whether Kasigluk, Tooksuk Bay. And we noticed that their cost of wind energy was roughly 25 cents per kilowatt hour. And we do have a couple high penetration systems in the state, including Wales, which at this point is being renovated. Interesting for those of you who have followed Wales over the years, there has been funding thanks to the Emerging Energy Technology Program to get Wales functioning as a high penetration system as it was originally intended. So this is in St. Paul Island, where they do run diesels off. And in March 2008, diesels ran only 27% of the time. And Hedo Coleman is here from TDX Power, and we'll be talking a little bit more in depth about this project. So, and then on to Kodiak Island, where, as I mentioned, they've installed the first large-scale wind turbines, and it's a unique system because they operate mostly on hydro. So it's a wind, hydro, diesel system. And here, where the diesels are typically operating as the baseload, hydro is. And they have average capacity factor of 33%. And I think I like this picture a little bit, the duct tape airplane. I think it shows a little bit that Alaska wind diesel and any remote wind diesel sometimes takes a little bit of innovation and ingenuity, and that's really where this market is right now, where because of the high growth that we're seeing in wind diesel, we're seeing a lot of innovation come out of developers that are working in this industry, including foundation design, which for those of you that were here yesterday got to hear a little bit about Kaufman Engineers and Goldner and Associates advanced foundation designs, which are now cutting costs across the state. So these are things that as we look forward into the future with innovations, we're going to see a lot of new things happen with wind diesel, and it's pretty exciting looking into the future. So to wrap up here, I wanted to conclude about our summary. Are wind installations in Alaska meeting our performance expectations? So this is based on our power cost equalization reports and comparing this to our model estimates of what wind systems should be producing in their wind regime based on their turbine installations. So you can see here that some of the earlier installations like Wales, Kotzebue, and Selawik have had difficulties over the years, primarily due to the turbine manufacturer. Everyone's familiar with those difficulties. So as we go forward, you can see that some of the systems that are having higher capacity factors are all in Class 7 wind regimes, St. Paul Island and Kodiak Island. There's certainly something to be said for experience, where AVEC has at this point a somewhat cookie-cutter approach where they're refining their installations with every single new project. And private funding, we've noticed, has had significant positive impact. It allows projects to move at a very quick, more quickly, and taking advantage of construction seasons and weather when it's available, and ultimately makes the wind project more economical for the residents. So it was reassuring to see after this study that the direction that we're heading in wind diesel systems in Alaska is on an upward trend. So where some of the initial demonstration projects, really those projects that pushed forward this technology for the first time in the state, really proving that it works, into systems now where we're seeing these systems being installed and meeting our performance expectations. And when we originally looked at this graph, I was trying to figure out what if there was any trending for amount of penetration of wind on a system compared to its capacity factor, compared to the cost of energy throughout the communities. And at first it was kind of a clean chart when we didn't have much data. And as we got more and more data, this chart became more and more complicated. And I think this highlights that there really isn't one simple solution there isn't necessarily a golden ticket for the type of systems that should be installed, but rather a combination of factors, including the ones I've already mentioned, of utilizing private funding and tax incentives, having a higher penetration systems, utilizing economies of scale. All of these things can make a wind project more affordable. So I just wanted to highlight some of the research that we've been doing at the university, just to make you aware. We'll hear more about this as we go throughout the conference, but we've recently been working on an EPSCoR award. This is an experimental program to stimulate competitive research at the University of Alaska Fairbanks. And they've selected the Alaska for wind diesel as a high priority research area for making wind work in Alaska, and specifically supporting the development of sustainable, resilient, cost-effective wind diesel systems for isolated communities. So while this is centered in Alaska, I look forward to reaching out to other researchers in other parts of the world to ensure that we're collaborating on our research. So just wanted to highlight our funding partners in this research and in WIDAC in general: the Alaska Center for Energy and Power, Alaska Energy Authority, the Denali Commission, the Alaska Housing and Finance Corporation, RollCap, and the U.S. Department of Energy, DOE EPSCoR. So I have the contact information for both Ginny Fay and myself, and as I mentioned during the poster session on Thursday night at 4 o'clock, as you can see in at 4:30, as you can see in your program, we will have some of our reports available. And thank you for your time.
Thank you, Kat. Any questions for Kat about the current market in Alaska, WIDAC, as well as the study that she and Jenny kind of pulled together? Absolutely no questions?
Oh.
Denali?
The power purchase agreements, is there a template that is underway that could be used in other circumstances? I know that Nome was one that's being held up as a good example. Is there a template that folks can use, or is Nome in a situation where they might be able to share that document?
Yeah, so Denali was asking the question about power purchase agreements and whether, this wind diesel power purchase agreement is something that could be used as a template for other similar projects in the same situation. And having discussions with Ian Graham and Gerald out at Sitnasuk, that is something that they're interested in doing, and they're willing to share that template if there's interest. So I would say yes, it's not that there's a formal template out there. I think there's a lot of varying factors which are going to change from project to project, but I think they certainly will be a resource to the next project in that same position where they can utilize their experience. Okay, great.
Any other questions? One other question. Yeah, press the button a little for a second or two and it should turn off. The light should come on.
Yeah, just a question on the Nome project, a bit technical. Just wondering what sort of measures they took to get that capacity factor up from 6% to 23-24%.
Yeah, good question, and I really wish that Ian Graham from Western Community Energy was able to make it, but unfortunately he couldn't be here at this event. But one of the things that they've had to do was reset the tolerances in the gearbox. So they actually had to come up with a unique mechanism to take the gearboxes down without lowering the tower. And so they were changing out components on the gearbox, you know, in the middle of the winter. And they came up with some pretty ingenious ways to do so. So those were complications that they've had. They had to reset the pitch. Because of the increased air density out at Nome, they were having a lot of overcurrent issues that were causing faults with the utility, so they had to reset the pitch. They've had to caulk any seam, any opening that existed with the tip brakes and any places along the blade, and that was a big problem because they were having water seep in through the cracks and causing electrical issues. And then the tip brakes themselves have been a significant problem for them, and they're probably on design. They've been working closely with Kotzebue and with AVEC to come up with a better solution for tip brake design, which won't have so many tendencies to fail. But currently there's quite a few different designs. All of them are based on, you know, mechanical springs or some sort of steel, which there's a lot of engineering challenges that they've had to face, and so he's currently under a new design for that. So hopefully it's kind of a combination of all of these issues, one after another, and they had to outsource a lot of their parts and come up with new ways to get them there. So I'm sure there's a lot of people that could speak better about specific hurdles they addressed, and so, okay.
Any other questions? Great, thank you, Kat.